This question is from GATE Mechanical Engineering of 2014. This is question number 45 of set 2. The question is, consider laminar flow of water over a flat plate of length 1 meter. If the boundary layer thickness at a distance of 0.25 meter from the leading edge of the plate is 8 millimeter, the boundary layer thickness in millimeter at a distance of 0.75 meter is. So first let's understand the relation between the boundary layer thickness and its distance from the leading edge. Now suppose this is the leading edge of the flat plate. This yellow line represents the top surface of the flat plate and this white curve represents the variation of boundary layer thickness over this flat plate. Okay, so let's say suppose at some point x, let's say this is a distance x from here. At this point, this is the boundary layer thickness. Okay, so this height is, let's say, delta. Okay, this is in laminar region. The relation between this delta and this x is given by Blasius equation. Okay, so for laminar flow, the relation between delta and x is given by Blasius equation. Okay, and according to the Blasius equation, delta is equal to 5 times of x divided by the square root of Reynolds number at that location x. Okay, and we know that Reynolds number is given by rho v d upon mu. So delta is equal to 5x divided by square root of density into velocity. So this is the flow velocity into x upon the dynamic viscosity. Now here the density, the dynamic viscosity and the velocity is assumed to be constant. 5 in itself is a constant. Therefore we can say that this boundary layer thickness delta is directly proportional to square root of x. Now according to the problem, this was x1 and if we increase it to point this, suppose this point from leading edge, this point is x2, this length is x2. So at this point, what will be the boundary layer thickness? Okay, let's say this height is delta 2 and let's say this is delta 1. So from using this relation, we can write delta 2 upon delta 1 is equal to square root of x2 upon x1, right? And according to the problem, x2 and x1 are given. Also delta 1 is also given, right? Now x1 is 0.25 and x2 is 0.75 and delta 1 is 8 millimeter. Okay, so let's substitute these values here. So from here we can write delta 2 will be equal to square root of x2 0.75 divided by x1, which is 0.25 multiplied by 8 millimeter. So delta 2 will be equal to 13.86 millimeter. Okay, so let's fill in the blank here. So the boundary layer thickness at 0.75 meter from the leading edge will be 13.86 millimeter. Okay, we have to find the answer in millimeter only. For more information on this topic, you can refer to the NPTEL course lecture number 36, Flow over a flat plate, Blasius equation on Advanced Fluid Mechanics by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.